Hello, today I'm going to do example 1 from section 9-1. A study of 200 randomly selected occupants in passenger cars and 250 randomly selected occupants in pickup trucks shows that 91% of occupants in passenger cars and 83.2% of occupants in pickup trucks wear seatbelts. At alpha equals 0.10, can you reject the claim that the proportion of occupants who wear seatbelts is the same for passenger cars and pickup trucks? So since this is talking about a proportion and we have two samples, this will be a two-prop z-test. So for a two-prop z-test, both samples need to be randomly selected. They need to be independent, so assuming that a person either drives a passenger car or a pickup truck and not both, we can assume independence for this one. The number of successes and failures need to be at least 5. And 91% successes of 200 is definitely bigger than 5. And then 9% failures of 200 is bigger than 5. And similarly, 83.2% of 250 and 16.8% of 250. So we meet that requirement as well. So let's get going with the hypothesis test. So we need our null and alternative hypotheses. And since it wants to know if it is the same, the claim is our null hypothesis with row 1 equal to row 2. And then the alternative is the opposite of that. So row 1 is not equal to row 2. Next step is to draw a picture. Since this is a proportion z-test, it's a normal distribution. And because the alternative is not equal to, it's a two-tailed test. And the area in each tail is 0.05. Next, to calculate the test statistic, we are going to use the calculator. So on the calculator, I can go to test, z, and 2p for 2 proportion. I need to choose the alternative hypothesis, which is not equal to, so F1. X1 is the number of successes, which would be 200 times 0.91. Well, I don't feel like going anywhere, so I'm going to just type in 200 times 0.91. When you hit enter, it calculates it for you. Remember, if this was not a whole number, you do have to round it. Only whole numbers allowed. And then N1 is 200. X2 is 250 times 832. Which is 208. And N2 is 250. We can skip the save result and execute. And we get a test statistic, or Z star, of 2.42. This one I am going to do the critical value method, so I'm going to ignore the p-value for right now. So because this is a two-tailed test, we need 2 critical values. To find the cutoff value based on the area, we need to use an inverse function. And since this is a normal distribution, we're going to use inverse norm. So when we go to inverse norm, which remember is under distribution, normal, INVN. Make sure the data is on variable instead of list. I'm going to do left because I'm calculating the left tail. The area is 0.05. Sigma will be 1 and mu will be 1. Or 0. Mu will be 0. Sorry about that. So we get negative 1.64. I could do the same thing for the right tail, or just know because of symmetry, this will be positive 1.64. So now I look at Z star, which is 2.42, which falls over here, to know that my test statistic is in the rejection region. So since Z star is in the rejection region, we reject the null. Since the null was our claim, that means we reject the claim. So there is sufficient evidence to reject the claim that the proportion of occupants who wear seatbelts is the same for cars and trucks. Now, it's because we use the word reject is why we say is the same down here, or we could say there's enough evidence to support or that they're not the same. But since we want to say we reject the claim, we're going to stick with this wording. And that's it for example 1.